Okay guys, let's take a look at lesson 3, vertex form with parameters p and q. I don't mean to jump around, but we're going to start on the page 8 where it says y equals x squared. And we want to investigate that. It says for any number x, its square y is a function of x. This is a quadratic function with equation y equals x squared. So what I want to do is I want to just create a simple little table of values where I'm going to put numbers in around the origin. So I'm going to put in values of -3, -2, -1, 0, 1, 2, and 3. And if I do that and I take those values and then I square them, -3 squared is of course 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, and then we get 1, 4, and 9. So when we plot those points, -3, 9, -2, 4, -1, 1, etc., what we get is we get not a linear function, right? Because in grade 10, we were to study quite extensively y equals mx plus b, which is a function with a degree of 1, okay? The degree here being little 1 right there, and that's a linear function, okay? So now in Math 20, we're really looking at a degree of 2, okay? A function with a degree of 2, and this is a quadratic function. And now this is our basic quadratic function of y equals x squared. Sometimes I've heard it called like an identity function. So that's what another thing we could call it. It's just the basic, most simplest, raw quadratic function, y equals x squared. Okay? Now it says the graph of every quadratic function is called a parabola. The curve is called a parabola. The characteristics of the parabola are listed below. Label them on the graph. So the vertex, we can see the vertex. The vertex is like the summit, either a lower or an upper summit. So our vertex here is 0, 0. Okay, there's our vertex of 0 and 0. Our maximum value, well, there is none because the graph goes up to infinity and beyond. Okay, our minimum value, when I talked about the minimum value, that's like the minimum. If I said, what's the minimum of your value, the minimum height, if I say, what's the minimum you're going to grow, the minimum value is like the height. So we're looking at the y, and the minimum y is a 0, okay? So my minimum is 0 when x equals 0, okay? And here's our minimum. We can label that as well, minimum. Okay, the axis of symmetry, and actually I'm going to actually change this. This should just say equation of axis of symmetry. Okay, and the equation of the axis of symmetry is where would we break this graph in half and fold it in half? We would fold it in half right down the middle through the vertex. The equation of that line, that vertical line, the equation of that vertical line is x is equal to 0. And that's the equation of the y-axis. Okay, the equation of the x-axis, incidentally, is y is equal to 0. But we're looking at this vertical line here. The equation there is x equals 0. Okay, my x-intercepts, well, there's just one right here on the x-axis. So there's the x and the y-intercept, okay, which are 0, 0, and 0, 0. The domain, if we look at the domain, the smallest x value, if we think about this graph, the left and rightness is it's going to go forever to the left and forever to the right. So our domain is the set of all x's such that x is all real numbers. And our range is the set of all y's such that y is greater than or equal to 0. Right? Our smallest y value here is 0, and then we go up to infinity. So our x, we go to -infinity and +infinity, and our range, we start at 0, and we say y is greater than or equal to 0. Okay? Now we'll look a little bit more about with this after. We haven't had to look at this. These are just some of the things that I'm talking about here. The graph of a quadratic function is a parabola. Here's some examples of what they look like, etc., etc. We'll come back to that in a bit. So let's just explore. It says investigate. For the following equations, complete the table of values, plot the graphs, points using a different color, and for each equation, complete the chart below. So we've already done this with y equals x squared. This is 4, 1, 0, 1, and 4. So I know a trick for how we can graph this. I always want at least 5 points to graph my parabola. So once I know where my vertex is, which is at 0, 0 for this particular graph, I know that to find my other points, I can move left one, and right one, up one. Left one, up one, right one, up one. I can move left 2, up 4, and right 2, up 4. And the reason I do it like that is because there's a pattern, and I know that if I'm moving right 1, 1 squared is 1. If I'm moving right 2, 2 squared is 4. If I wanted to find the other points, if I move right 3, 3 squared is 9. And the reason I want to introduce you to the pattern is because we're going to be moving graphs around, moving our vertex around, but once we move it, we don't have to look at the individual points because we understand what the graph kind of looks like. So there's our y equals x squared. Let's look at the next equation. We've got y equals x minus 2 all squared. So in this case here, for this y equals x minus 2 all squared, x has been replaced with x minus 2. So what do we think might happen to the graph? Well, I've had students say it looks like the graph might go left too because it's x minus 2. It looks like we might move up 2 or down 2. So there's all kinds of guesses. Let's figure out what happens. So because x has changed, I'm replacing x with x minus 2. What I want to do is I want to look at another point on my graph. So I'm going to take, I can take any point. I'm going to take 2, 4, and I want to leave the y value the same. And I'm going to sub that in when y is equal to 4 on my original graph. What happens to x? Okay, up here when y is equal to 4, x is equal to plus or minus 2. So what about down here? If I take x and replace x with x minus 2, what happens to that? What happens to my function? So let's do that now. If y is equal to 4, I'm going to sub that into my y position, and I get x minus 2 all squared. What I want to do is I want to solve for x to see what happens to my individual points. So when I take the square root of both sides, right, of course, that's how I want to isolate x, so I take the square root. When I take the square root of a number, though, I know there's two answers, so I have to do a plus or minus the square root of 4. Just as a reminder, what I mean by that is if I have something like x squared is equal to 16, for example, well, there's not one value, there's two values we can put in for x that will give us 16. We can put a positive 4 squared is equal to 16, or a negative 4 squared is equal to 16. So to ensure that I don't forget one of those values, when we take the square root of both sides, what we do is we have to take the plus or minus the square root of 16, so x is plus or minus the 4. So the same thing down here, we're taking the positive and negative square root of 4, which is plus or minus 2, and that gives me x minus 2 equals plus or minus 2. I want to solve for x, so I'm going to isolate the x minus 2, isolate the x by moving over the minus 2, and that becomes a positive 2. So we end up here with 2 plus or minus 2. Okay, let's move the 2 here. 2 plus or minus 2 equals x. So x is equal to 2 plus 2, and x is equal to 2 minus 2, which is 0, which I'm thinking that faster than my hand can write, and 2 minus 2 is 0. So now instead of our points being negative 2, 4 and 2, 4, now our two coordinates are 0, 4 and 4, 4. So where is that? 0, 4 is right here, and 4, 4 is right here. What has happened to our graph? Our graph, if we were to plug in, even if we plugged in the 0, 0, if y is 0, and we want to solve for x, square root of 0 is just 0. So x would be equal to 2. So what's happened to the vertex? The vertex is now 2, 0. Look at that information. Here's my new vertex. It's moved over 2 to the right. Okay, so we've moved right 2. How can that be? That's how it can be. Now if I know my vertex is here at 2, 0, then I know I want to go over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4, over 3, up 9, and left 3, up 9. Okay, and I've actually got my 7 points, right? We kind of like at least 5, but there's our 7 points for y equals x minus 2 all squared. What about x plus 1 squared? If x is replaced with x plus 1, if we were to put that in our calculator or solve, we would see that we end up going left 1. Okay, so let's do that in maybe a red color. Okay, our graph is going to move left 1. And again, over 1, up 1, over 1, up 1, over 2, up 4, left 2, up 4, right 3, up 9, and left 3, up 9. And there is my new graph. Now note all of these are the same shape. We have just shifted the graph left or right 2 or right 2 or left 1. Okay, if we were to look at the coordinates here for the blue graph that we moved to the right 2, this becomes 4, this is 1, 0, 1, and 4. So all of our y coordinates have stayed the same. It's the x coordinates have changed. And same here, this one here, this is when x is here regularly when x is negative 2, y is 4. Here when x is negative 3, y is 4. So our graph has moved left 1. Okay? And we don't have to necessarily investigate each individual point, but that's the idea. Now, we've already filled in the first graph. I'll fill in the second one, and then I'm going to give you guys a second to, I'm going to pause the video and let you fill in the next one. So our vertex here was 2, 0. Let's do our blue graph first. 2, 0. Our maximum, there's no max, but our minimum is 0. So our minimum comes from, where does our minimum come from? Our minimum comes from the y value of our vertex, right? We can see it right here on our graph. Our minimum is 0 when x equals 2, okay? The y-intercept for this blue graph was 0, 4. The x-intercept was 2, 0. The equation of the axis of symmetry, so let's just do that maybe in a light blue color, and that goes right down here, right down through where x is equal to 2. And again, where's this information coming from? Or as a hint here, the equation of my axis of symmetry, whoops, I meant to do that in highlighter, comes from the x coordinate here of my vertex, okay? That's where the equation of the axis of symmetry comes from. So that one there is x is equal to 2. And then our domain for all of these, for all of our parabolas, is going to be the set of all x's such that x is all real numbers. And then our range is the set of all y's such that y is greater than or equal to 0 for this particular graph. Okay, so I'm going to pause the video and let you complete the first one here and maybe the third. Yeah, we'll just pause that for a second. Give those a try if you can. Okay? Okay, so hopefully you had a second or a minute to try that and were able to complete those values there. In general, it says the graph of y equals x minus p all squared is the graph of y equals x squared moved along the x-axis. Okay, moved along the x-axis. It moves left p units if p is less than 0. So if p is negative, we go left. So up here, this is a p is negative. P is negative 1 here because this is y equals x minus negative 1 squared, right? When we make this into a form with a negative, the p is the opposite of what we saw here. So example, this is a positive 1 there, a plus 1. The p value is actually a negative, and that comes from x minus negative 1. Okay, if we look at x minus 2, well, that's the same as x minus a positive 2, right? If I say I've got 7 minus 3, that's the same as 7 plus negative 3. So this here, we're moving right when p is positive. P is greater than 0. Okay, here my p value, p is positive 2. Okay, because the minus comes from that equation. Okay, so hopefully that makes sense. It gets a little confusing because we're going back and forth there. The next one says determine the vertex and the p-value. So here our vertex is 4, 0, and our p-value is 4, okay? Because this is x minus positive 4 squared. That's another way of thinking of that, okay? This one we can think of this as x minus negative 6 all squared. Our vertex is, of course, negative 6 and 0, and our p-value is negative 6, okay? Our p-value is the first part of our vertex, the x-coordinate of our vertex. Okay, y equals x minus negative 10 all squared. Our vertex is negative 10, 0, and our p-value is negative 10. Okay, and then this last one, of course, our p-value, right, we've subtracted nothing. This is the same as y equals x minus 0 squared. So our vertex here is 0, 0, and our p-value is 0. Okay, note the p-value comes before the after after the subtraction sign. Inside the brackets, the p-value is always the opposite sign than the number in the brackets. The p-value moves the parabola along the x-axis, or the horizontal axis. Okay, let's do the next investigation for the following equations. Y equals x squared, y equals x squared plus 3. Again, we know this one. This is 4, 1, 0, 1, and 4. If I take those values now, my y equals x squared values, which I have over here, and I add 3 to all of them, we get 7, 4, 3, 4, and 7. So what's going to happen to our graph? We know our original function. Let's just pop it out here in green. Over 1, up 1, over 2, up 4, left 2, up 4, up 9, up 9. Okay, over 3, up 9. So there's our original function, y equals x squared again. And then what's going to happen here? Now instead of negative 2, 4, we're at negative 2, 7. So let's see, negative 2, 7, whoops, negative 2, 7 is right about there. Okay, instead of negative 1, 1, we're at negative 1, 4. Negative 1, 4. And 0, 3. And 1, 4. And 2, 7. So what's happened to our graph? The whole function has moved up 3. Okay, we can see that on our graph. Okay, and the whole thing, it's the exact same shape. Might look a little skinnier just because we have a smaller portion of it. Okay, but it's the same shape. This is our y equals x squared plus 3. Okay, and now let's look at the next one. Let's do a new color here. We haven't done any pink. Y equals x squared minus 2. So we're going to take all of these x squared values, 4, 1, 0, 1, and 4, and we're going to subtract 2. So 4 minus 2 is 2. 1 minus 2 is negative 1. 0 minus 2, negative 2, and so on. Okay, 4 minus 2 is 2. So we're just subtracting 2 from all of our y values. And of course, our whole graph is going to move down 2. Now, if I recognize that 0, negative 2 is my vertex, which it is, and once there, I could either move all of these individual points down 2, okay, each individual point, or I can say, well, I know my vertex is here at 0, negative 2, and I know I'm going to go right 1, up 1, right 2, up 4. If I wanted, I could go right 3, up 9, which would take me up to the coordinate of 7 right here. Okay, that's the first half of my parabola, and the same thing here. Left 1, up 1, left 2, up 4 from my vertex, or left 3, up 9, which takes me to negative 3, 7. Okay, so there's y equals x squared minus 2. And of course, they want us to fill all this in, so I'm going to pause the video and let you complete. We've got this one. This is the same. Let's do that in green. This is the same as we've done a couple of times, so you can copy that over. But let's look at the next two. I'm going to give you 5 seconds here so you can pause the video and try the next two. Okay, so hopefully you had a minute to fill in these values. You may have gotten a little bit stuck on the x-intercepts here for this graph. So what I did is I just solved. Okay, these values here, I said, well, when y is 0, what are these values? And that there is the square root of 2 and 0. That's the point of the x-intercept. And this other one is negative root 2, 0, leaving those as an absolute value. You could put those in your calculator as well. But there we go. Y equals x squared minus 2. I let y equal to 0. I isolated the x squared by moving over the negative 2, which becomes a plus 2. and then I had 2 is equal to x squared, and I took the square root and got a plus or minus square root of 2. So there's where our x-intercepts. The rest I think is probably fairly straightforward as long as you're following along and understand. Okay, in general, the graph of y equals x squared plus q is the graph of y equals x squared moved along the y-axis up q units if q is positive or greater than 0, down q units is if q is negative or less than 0. Okay, let's look at the next page. This says investigate y equals p squared plus q. So now we're combining the two. Okay, I'm not going to draw y equals x squared here quite yet, but I know, because I know we've got that. We've done that many times already, 3 times. Here I know I'm going right 2, the opposite of what the sign looks like, and here we're going to go up 3. Okay, so if I'm looking at this first graph, my new vertex, when my vertex is normally 0, 0, my new vertex is going to be 2, 3. Okay, my new vertex is going to be 2, 3, moving from 0, 0 to 2, 3. So where's that new vertex? 2, 3 is right here. Okay, and now I know how to draw this thing. I don't even need to look at the other points. I'm going to move right 1 up 1, left 1 up 1 from the vertex. Right 2 up 4. I'm literally just counting 1, 2, 1, 2, 3, 4. Right 3, 1, 2, 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, we'd be off the grid there. Okay, left 1 up 1, left 2 up 1, 2, 3, 4. Okay, so because I held that down, I accidentally made that. So I'm going to get rid of these little squiggles, but you get the idea. That's literally what we're doing. We're just counting. Okay, we can all count spaces. Okay, and left 3 and up 9. So our graph would look something like this, right? It's moved. And of course we could take the individual points, but we don't really need to. Okay, here when x is 0, y is 7. Here when x is 1, y is 4. Okay, here when x is 2, y was 3. There's our vertex, right? When x is 3, y is 4. And when x is 4 here, y is 7. Okay, so there's our points. I just looked at them off the graph. Okay, but much easier once I know that shape to just move along from there. Let's try the next one here. Why don't you guys try the next one? Okay, why don't we fill out this down here? I know the vertex comes from here. My vertex, let's fill out this first table together, and then the first row here. This is the same again, the y equals x squared. Okay, but this, my vertex is 2, 3, which we can see there. The max, where's the maximum come from? The maximum comes from the y value of the vertex, right? How tall are you going to get? Or the minimum, right? In this case, there is no max, okay? But there's a minimum. So our minimum is 3 when x is 2. Okay, is there a y-intercept? Our y-intercept is right there at 0, 7. So I'm just looking at the graph. The equation of the axis of symmetry, well, that, of course, would be right down the middle, where x is equal to 2. Okay. There's our x equals 2. And remember, the equation has an equal sign. You don't want to just say 2. Okay, another way to write this, by the way, you could say x equals 2 or x minus 2 equals 0. Sometimes you see that. Domain, instead of all x is all reals. Range, y is greater than or equal to 3. Okay, I'm going to pause the video and let you guys complete this one and the table below. Okay. Okay then, so in order for me to fill in this table, I started with the vertex. I knew I was going left 1 and down 2, so I knew my vertex was -1, -2. Okay, so I started there, right on my graph, right there. Vertex, -1, -2. And then I drew the graph from there, and then I got the coordinates of the points, okay? There's a couple of ways you could have done that, but that's probably one of the easiest or the quickest. And then I filled in the table down here. my vertex -1, -2, my min -2 when x equals -1, etc. So you can check your own answers there if you need to pause the video. The last thing is we've kind of got this general formula. So we know that for this vertex, our vertex is always P comma Q. Okay, whatever our P value is and our Q value. Our maximum or our minimum, where does that come from? Well, our maximum comes from the Q value. Okay, so our max is Q, or we could say max is equal to Q when x equals P. And then our y-intercept depends. Okay, it depends on the graph. Okay, we can't figure that out so much in this case. Okay, the equation of the axis of symmetry, well, that comes from where our line of the axis of symmetry would intersect the x-axis. Okay, so here the equation of the axis of symmetry was x equals -1, and here the equation of the axis of symmetry was x equals 2. So it's the p value of our it's the p value of our vertex. So we would say here x is equal to p, or x minus p equals 0. Okay, the domain is always, no matter what, all real numbers, and the range is going to be y is greater than or equal to q. Okay, so there we are in a nutshell. Vertex form summary. So describe how the graphs of the functions in each pair are related, then determine the vertex, the equation of the axis of symmetry, the domain and range, any intercepts, and sketch the graph of the second function in each pair. So we're going to do a basic. We may not cover all of that right now, but we're going to do a basic. Now the first thing is the description. What has happened here? The description. X has been replaced with x plus 2. Therefore, we've got a horizontal shift. We can call it a horizontal shift 2 units left. Okay? And then this q value, q is equal to -4. Therefore, we are going vertical shift 4 units down. Okay? That's our description. Then determine the vertex, the equation of the axis of symmetry, etc. So our vertex here, right? I know that if I think of this as y equals x minus -2 squared minus 4, my p value is -2 and q is -4. So our vertex is -2, -4. Okay? The equation of the axis of symmetry will come from here. X is equal to -2, or x plus 2 equals 0. There's the equation of axis of symmetry. Okay? The domain and range. The domain is all real numbers, and the range, y is greater than or equal to -4. Okay, I'm not going to worry about the intercepts right now, but if I were to sketch the graph of this function, you know, let's just do a mini sketch, nothing fancy. Where are we? -2, -4. So I'm going to go like this. Okay, -2, -4. I know that my vertex is right here. If I had a nice grid, whoops, I didn't mean to bump that, I would move over 1 up 1, over 2 up 4, left 1 up 1, left 2 up 4, and there would be a basic sketch. Okay, and actually I think we can find the x-intercept. The x-intercepts are, we move from -2, we move left 2 and up 4, so that is the point -4, 0. And this is the point 0, 0. So of course our x-intercepts is -4 and 0, okay, -4 and 0, and our y-intercept is equal to 0 right here. Okay, we'll omit this one. We've done enough for today. So that's great. I would suggest you do all of the questions on this in this assignment. That would be awesome. Thank you.